Hello, today we are going to discuss about the basics of creation of a structural joint or fitting in PDMS design and the correlation and connection and working philosophy in between design and Paragon. And we'll also understand how the specifications are correlated in between the PDMS design graphical user interface as well as with the Paragon specifications and every in between detail. We will understand all the working philosophies today, and later in other episodes we will go and create different specifications, different categories like that. So for that, first of all, we will see how to create an end section joint or a section to section joints. Okay. So there are basically two kinds of joints in PDMS structure. So one is end section joints, that is a joint which is created at the end of a section. Okay. Like end plate or base plate. So for an end section joints, there will be only an attached section, the section that is going to be attached with that joint. Okay. There will be no owning section for that end section joint. But for a section to section joints, there will be one owning section. Okay. It will be clear later on while we discuss it in detail. Okay. So first of all, we have to go to design structure and beams and columns. After that, we have to go to modify joints and specification. After that, we have to click on that end of the section of the attached section. Okay. The section that is going to be attached via the joint. Okay. So we will click it here, but as you can see that an error message has popped up saying that we have to turn our pinode creation on. Okay. This is a very popular error message. So to dismiss that, we have to right click on this toolbar, and first of all we have to open this beams and columns toolbar. Okay. This is the beams and columns toolbar here. So you can see that there is one eye profile section, and just before that there is one primary node. Okay. This is displayed as primary nodes. This is the P node. So we have to click it to turn it on. Okay. So after turning it on, again after that there are two tabs. Okay. The first tab is the storage spaces for our structural members, and the second tab is for the storage spaces of the P nodes. Okay. There you can see a red dot, and there you can see the one I beam kind of thing. Okay. So this section is the storage spaces for all the structural members, and the next section on this one is the storage space for the P nodes. Okay. So first of all, we will click this framework, as this is going to be the main storage section for our structural members, and we will click it here. Okay. So now as you can see that this is our storage space for our structural members, and this is linked, interlinked. So this is highlighted. Okay. Now we will click this framework, and again this is going to be the storage space for all our P nodes or in section joints. So we will click here, and you can see that this is highlighted, means now this is the storage space for all the P nodes. Okay. After that, to create an in section joints, again we have to go to modify joints and specifications, and again we have to click at that end of the attached section. Okay. If you click it this end, it will be created this end. If you click it here in this end, it will be created at that end. Okay. So now we are looking for the creation of an base plate. So it is the base of this column. So we will click here. Okay. So now as you can see that end section joint is already created. Okay. So we'll go here and we will click on base plate, and we'll select any of this component, and this is the base plate. This is how an end section joint is created in PDMS. Okay. So there are other properties like that. When we create one detailed end section joint later on, we will see that we can modify it like in very detail, but in this case there is, I think, only one modify properties, that is one design parameter, that is the diameter of the bolt. You can change the diameter of the bolt by changing it from here like this. This is only one design parameter here. Okay. Anyway. So this is how you will create one end section joint. Okay. So now after that there is the section to section joints. Okay. So for creating the section to section joints, first of all, you have to connect this section. This is the child section. You have to connect it to the mother section. There is a column in our case. Okay. So for that, we have to go to this connect tab, click it here, and then we will click the connect. Then first of all, we have to select the mother section. Okay. Up to which the child section will be trimmed. Okay. So first of all, we will click the mother section, and after that we will click the child section. Okay. The section that is going to be connected to this mother section. This is the parent section. So after connecting it, we'll click it here, and we will click on escape. Okay. As you can see that a joint has been created in this place. Okay. So this is the joint. Okay. Now, as I have already said, I think that the end section joints there is no owning section in this case. Okay, so we have to create a storage space for here. In this case, this is this subframework where all these in section joints will be stored. Okay, there is only one attached section, that is this column section, but for a section to section joints, as you can see that this is our joint. Okay, so this is our joint. So this is our joint, and this joint is under this section, this SCT and C5. So there is one owning element, and in this case for this section to section joint, the owning element is SCT and C5, and this is the attached section. As you can see, this is also highlighted because it has been trimmed. So this is the attached section. Okay, if we go to modify joints and specification and click it in this end, the attached section. Okay, and we will go to column connections and we will click it here and apply. Okay, as you can see that the joint has been created. Okay, so again you have to go to modify joint specification, and you have to click on that end, the end that you are going to create the joint of the attached section. Okay, so this is the attached section. After clicking it, you can select it anything like that. So like that. Okay, like that. So this is the basic procedure of creating any end section joint or section to section joint in PDMS design. Okay, now we will check how all this thing is happening and how all these things are correlated in between Paragon and design. Okay, only then we can create different kinds of fittings, joints, end section joints, section to section joints like that, and we can modify it further and further on. Okay, so first of all we will concentrate on this end section joint. Okay, so for this end section joint, as I have already said that there are no owning section, so it is created under this subframework. So there are no owning section. So this is the PJOI, and we will check the spec ref of this one, SPREF, and we will just copy it from here and go to Paragon. Okay, so this is the specification base plates. Okay, this is the specifications. But before going into detail regarding the structural specifications for joints, just let me clarify something regarding the specifications and their different selectors and spec components. Why it is necessary? It is necessary because, just for reference, if I go to a piping specification, okay, just let me go to any piping specifications, the default piping specification that is already available with PDMS like A1A. So if I click it here, as you can see that this specification is not read only. Okay, so you can add your headings, add new items like that. In piping we can create any item, any category, and we can add it through this graphical user interface. But for structural specifications like joints or fitting specifications, if we check the current element here, you can see that this is read only. You cannot add heading or add new items through this dialog box. So we have to go through the command window procedure. Okay, so for that we have to understand what are the specifications questions, what are their different types of answers, how the selectors are working, what are the hierarchy orders, how they're intercorrelated like that. Okay, so for that I am going to discuss it from a piping spec, because in that case it will be more easier, and then I will come to a structural specification spec for a joint or something like that. So just check on this current element and just we will take any of this heading first of all, like elbow, something like that. We will click on edit heading. Now as you can see that this is the elbow. Okay, so this is our piping specification. Okay, this is our piping specification. So the under the heading tab, okay, under the heading tab you can see that there are 5 different questions. Okay, the last question, that is a shop, the answer is true or anything like that, this is not relevant in our case. Okay, so the first 4 questions are the main relevant questions in our case. So I will look into that, how they are intercorrelated by these selectors. Okay, so this is the first specification. Okay, so this specification has asked us one question. What is the question? The question is the first question under the heading. That is, the question is type TYP. Okay, and the purpose is also written. In this case the purpose is pipe. In our case the purpose will be join, because that is the joint specification. You cannot see that specification if you mention any other purposes. I will show that later on. So the first question that is asked is type according to this heading. Where will we get this answer? We will get this answer under the first set of selectors. These are all the first set of selectors. In our case we have chosen the elbow. Okay, so as you can see, this is the elbow attribute tab. Under the attribute tab there is description, there is answer, maximum answer, T answer. Okay, This answer and maximum answer, these are for numerical value type answers. And then there are text answers like elbow or like. We will find all the text answers under the T answer tab, and we will find the numerical value answers under this answer and maximum answer tab. Okay. So what was our question? Our question was type TYP. Okay, this was our question. We have got the answer as elbow under the T answer tab. And as there are no numerical values associated with this, so the answer and maximum answer tabs are empty. Okay. So the question was TYP or type, and our first set of answer is ELBO, elbow. Okay. Now this selector will ask the second set of question under the heading. That question is PBOR. So this question asked is PBOR. Okay. So where we will get this answer? Definitely under the second set of selectors under this hierarchy. So suppose check anyone. Okay. So the PBOR. So now the PBOR is a numerical value. Okay. So in this case, we will get this answer under the answer and the maximum answer tab. Okay. And the T answer tab is empty because there are no text answers related to that. Okay. So now this selector that we have already selected will ask us the third question under the heading, and that question is ANGL or angle. Okay. So where we will get this answer? Definitely under the next set of selectors, and this is the next set of selectors. So again, this is a numerical value, so we will get this answer in the answer and maximum answer tab. This is the answer, that is 30, and the maximum angle that it can take is 90. Okay. And as there are no text type of answers, so the T answer tab is unset here also. Okay. Now this selector will ask us the last relevant type of question, that is the S type or subtype. Okay. The question is S type here. Where we will get this answer? Definitely under the next set of selectors. This is this. Now the answer is EL90 or S type or subtype is EL90. As you can see here also, this is the subtype EL90. It is a text answer, so the T answer tab is populated with EL90, and as there are no numerical values, so the answer and the maximum answer tabs are empty. Okay. Now under this selector there will be specification components like the normal specification components. Okay. So this is the general hierarchy of a specification. So what is the hierarchy? In this first case, the specification will ask us the first type of question, that is the type under the heading. We will get the answer in the first set of selectors, that is ELBO. It will ask us the second question, that is PBOR. We will get the answer in the second set of selectors, that is PBOR 250 in this case. Answer and maximum answer tabs are populated. T answer tab is empty as there are no text answers. Now this selector will ask us the third set of question, that is ANGL. Now the next set of selector will answer that. So the answer will be 30 and the maximum answer is 90. And as there are no text answers, so the T answer tab is empty, and this selector will ask us the last set of question, that is the S type or subtype. The question is S type, and it will be answered in the next set of selectors, that is the T answer, that is the EL90. Okay. And as there are no numerical values associated with this, so the answer and maximum answer tabs are empty. Okay. So this is the general hierarchy of a specification. Now we will go to the joint specification. Okay, for better understanding. So if we click on this specification and check the C. Okay. So this is our joint specification, and as we have already discussed, this is absolutely read-only, so you cannot include it through here. You have to go through the command window procedure, and that we will discuss on a later episode. Today we will be concentrating only on the procedure and the working philosophy and how they are interlinked. Okay. So first of all, the specification is for base plates. Okay. If we go to design, this is our base plate. Again, we have to go to modify joints and specification, and this dialog box is popped up. Okay. So as you can see, this is the specification tab, and this is the base plate connections. Okay. So where is this coming from? This text. Okay. This is the description of the specifications. If you go to the specification, you can see that this is the description, base plate connections. Okay. This is the description of the specification. For an instance, just delete here and make it connect, and just do a save work and go to design of it here. Then do get work and do another save work, and again click on modify joints and specification. You can see that this specification is changed to connect. Why? Because we have changed the description of the specifications in Paragon also. Okay. So this is how it is interlinked between the graphical user interface and Paragon. Just let me change it to what it was before. Just save it once and do a quick get work and save work, modify joint specifications, and now as you can see that it is restored to its previous glory of connections. So this is the specifications, and it is coming from the description of the specifications that is written in Paragon specifications. Okay. So what is the first question in this specification? The first question is O type. Okay, this is the O type, and the purpose is join. I will show later on in this episode that if you change the purpose of these specifications, it will not be shown under the graphical user interface tab. Okay, So what is the first set of question here? The O type. What is O type? O type is the owning section type. Okay. So as I have already discussed, for a base plate, okay, for a base plate there are no owning section. That is why it is created under another subframework. Okay. But for a section to section joints, definitely for a joint there is one owning section. For this case, this joint comes under the hierarchy of this column section. Okay. So for a base plate kind of connection or end joint, in this case our specification is base plate connections. So there are no owning section. Okay. So if you go to Paragon, so the first question is O type and definitely the answer will be none, and that answer we will find under the first set of selectors as we have already discussed from piping specifications, and the answer is here none. Okay, and as this is the text type of answer, so this answer and maximum answer tabs are not populated. Okay, so this set of selectors will ask us the second set of question. Okay, and that set of question is A type or attached section type. Okay, attached section type. So in this case, what is the attached section type for base plate? Definitely this is the section that is the base plate is attached to. Okay, so we will just select on this section and we will quickly check what is the G type of this section. As we can see, the G type is beam. Okay, so the question is A type and we will get the answer in the next set of selectors, and if you click the next set of selectors you can see the answer is beam. So what is the answer? How we will get this answer? This is the G type of the attached section. Okay, for a base plate. So this is the G type of the attached section, and as there are no numerical values, these two types are empty. So this set of selector will ask us the next set of questions, that is the S type or subtype, and we will get that answer in the next set of selectors, and it can be attachment, it can be defined, anything like that. You can change it anything you want actually. It will not affect in a much larger sense. It will affect one or two things that I will discuss later on in this episode also. So this is the last set of selectors. Okay, what was the question in the selector before? The question was subtype, regarding subtype. We will get the answer, that is subtype attachment, and we will get the description of the subtype as well, and the description is as attached section. That is the description of the subtype. Okay, so the question was asked in the previous set of selectors, that is S type, and the answer is ATA, and the description of the subtype is as attached section. This description you can see under this subtype as attached section. Okay, this is the description of the subtype that we can see from the last set of selectors description. This description has come to this. You can check by deleting it and get Foxever like that, and it is correlated. Just I have shown it regarding these base plate connections like that. Okay, under this subtype there are different kind of components. Okay, these are the components, these are the spec components. Okay, but this name is not name of the spec component. If you go to any spec component like this, you can see the name is different. Name is BPLT backslash beam backslash attach like that, but our name is different. What is our name? Our name is 10 or 30 millimeter underscore thick underscore attach underscore base plate like that. So this is the name of the cat ref actually. If you see under the specification component, this is the category reference. If you copy this, just put a backslash and paste and enter, you can see this is the category of the base plate, and the name of the category is referred in this portion. Okay, so this is the normal hierarchy of a base plate kind of specifications. Okay, the same hierarchy is followed for the section to section joint specifications. Okay, if you go to the section to section joint specification, the same thing has been followed. If you click in this and modify joints and specifications, this tab is displayed, and just check the SPREF of this. This is the SPREF. Copy it here, paste it in Paragon. Okay, perfect. So now this is the specification of the section to section joints. Okay, this is the specification. Again we will check this same philosophy. Okay, so the specification description, the column connections, as we can see, it is coming under the specifications tab in the graphical user interface dialog box. Okay, this column connections, it is same type of interlinked. So the first type of question is O type. Okay, that is the owning section type. In this case, what is the owning section? This section is owning this joint, this SC TNC5. Okay, this is the owning section in this case. And what is the attached section? This is the attached section in this case. That is C4 C51. Okay, this is the attached section, this is the owning section. So this is the owning section. What is the QG type? If we check it, we can see that there is a beam. Okay, so if you go to Paragon, we check that there is the owning section type is the question. We will get the answer in the first set of selectors, that is the beam. That is the G type of the owning section. Okay, perfect. Now this selector will ask us the second set of question, that is the A type or the attached section type. Okay, the attached section type. Now if you go to design, you can see that this is a beam definitely, but this base plate is created for any section. If you go to the next set of selectors to get the answer of this, you will see that this is any. Any means any section having any type of G type, if that section is connected to a beam. Okay, if any section having any G type is connected to a beam, and if you create a column flange connection for this beam, you will see this specification components for that as well, because for attached section no G type is specified. Okay, now suppose if you specify one G type, like suppose if you specify one beam here, okay, then only if you connect one beam to another I beam or I column like that, only then you will see this spec components. Okay, if you connect 150 MC 150 with the I beam, then you will not see all these things, because MC 150 will come under the parallel flange I channel like that. Now for a reference that I've already discussed here in Paragon, there is the selector question here at a section type, and the answer that we have got in the next set of selectors is, it was actually beam previously. Okay, it was actually beam. So if we give one save work and do one get work here, so for this P node, if you go to modify joints and specifications and click it here, so modify joint specifications here like that, so you can see that the base plate connections and every other subtype details and specification components, each of these things are shown. Why all these are shown? Because this is the attached section type, and the attached section type is actually the G type of the attached section, and here it is beam. Okay, like that, and the answer is beam also. Okay, so in this case, suppose if we add another section, okay, that is having another G type and not the same G type of beam, so here the G type is BSC and not beam. Okay, so for this section, if we perform the same act, okay, there is modify joint specifications, click it here, then we can see the joint is created here, and as the base plate connections are also shown here, but nothing else. Why nothing else? Because the base plate connections is the description of the specifications that we have already shown earlier, that we have already seen earlier. The first set of selector asks the question of the attached section type. The first set of selectors ask the question of attached section type, but the desired answer is beam, but it doesn't get that desired answer, because in this case, in our case, the G type of this section is BSC that we have already seen here. So it doesn't recognize the provided T answer in the Paragon, and hence it doesn't carry out the logic. It is like a logic gate. Okay, so this is the question A type. It will check here the answer. If it is true, that is if it is beam, or if the G type of this section is matching with the answer provided here, then it will go to the next selector and to the next selector and to the next spec component like that. But in this case, it has come across this question A type, and it has checked the G type of this section. Okay, G type of this section, but it has come across the G type of BSC, and it hasn't matched with the G type of this provided G type, that is beam. So it ends the logic in this selector. It ends the logic here, and as it ends the logic here, no other selectors have performed their actions. Okay, so for a examples sort of reference, we can do one thing. We just first of all delete this joint and just go here, and this is the first set of selector, and the question is A type, and this is our answer. We can change this to any, actually, just for a quick sort of references. So now it will define every other sections. Okay, so previously, now I haven't performed get work yet. So previously, if you go to modify joint specification, click it here under the base plates, you cannot see anything because this BSCG type was not referred there. Okay, but if you just delete it for once and perform one small get work and save work, and after that, if you go to the same sort of operation, modify joint specification and click it here, now you can see that under base plates everything is shown. Why everything is shown? Because now I have changed the answer from beam to any, means now all these things, all these actions, all these logic gates will be performed for every A type answers, because whenever they will check the G type of the section to get the matching answer, they will not find any discrepancies because the answer is any, answer is not beam. Okay, so for any sections you will get these base plates now. Okay, for any sections you will get these base plates now. Now if you click it, and you will see that this base plate is created. Obviously the dimensions will be different according to this owning parameter. So geometrically it is not correct, but it is defined there, and we will modify this in later episode like that. Okay, so now we can delete this, and if we change it to what it was before, to like a beam. Okay, so again, if you perform one small save work and do one get work here, then if you perform this action again, modify joint specification, click at the end of the attached section, then again we cannot see anything, because the same logic is again, that is, after specification first set of selector ask the question A type, the provided answer was beam, that is the G type of the attached section, but in our case the answer is BSC. So as there is a mismatch, so the answer is false, and as the logic gate answer is false, so no other selectors will perform their corresponding actions up to the specification components, and nothing will be shown under the graphical user interface. That is the total thing. That's why these questions are very, very important while defining all these specifications and selectors, as we are going to create all these specifications through command window itself. Now for our case, the attached section G type is any, means sections having any sort of G types, if they are attached to a section that is having a G type of beam, then under the section of beam G type, you can create a section to section joints, that is column flange. So now this set of selectors will ask us the next set of question, that is the S type. Okay, this is the next set of question, and we will get the answer in the next set of selectors, that is in our case the answer is wave, in our case the answer is flange. Actually joints can be created in column wave or flange, both. So now, as we have already discussed, so the last question was S type, and we have got the answer as flange, and the description of that S type is column flange. So if you go to design tab, you can see that same subtype description is written here also, that is the column flange. Okay. Now under column flange, as we have already discussed, there are different kind of specification components. These are all those specification components, and as we have already checked, the name of the category, the name of the category of those specification components are there under this tab. Okay, these are the name of the category of all the specification components that are under this column flange S type subsection. Okay, so this is the general hierarchy of the section. Okay, so now there is one catch up, as I have already told you that under this selector we have got the answer, that is wave and flange. This answer actually doesn't matter much, but for sort kind of thing this answer matters. That means, suppose in this case you can see that hierarchy wise this selector is above, the wave selector is above the flange selector. Okay, but if you go to this design tab and just again once again let me open this modify joint specification, you see that the column flange is coming above column wave. Okay, this is coming why? Because if you select on this column wave, you can column flange, sorry, you can see the answer is flange, and if you see this wave, you can see this WEB is the answer. Alphabetically, the flange answer is prior to this wave. Okay, so let's for a check, just let me change it to AA. Okay, so now this is alphabetically prior to flange. So currently, as you can see, the flange is coming before wave. Okay, in this sort. But if you change it like this AA, now just do a save work, and if we just close it, do a quick get work and save work, and then again let me open this window, you will see that column wave will come before column flange. Why? Because I have changed the T answer to a value which is alphabetically prior to that of flange. Okay, so the value doesn't refer to any other important parameters, only it will affect the sorting of those things. I think yes. Okay, just let me change it wave. Perfect. Okay, now this is the total procedure, the total interlink. Let me go through it once. So first of all, this is the specifications, this is the description of the specifications. The description will come under the specification tab. After that, a question will be asked. The first question is the owning section type. For a base plate kind of section, there is no owning section, as we have already discussed, so it will be created under another sub framework or something like that, or framework like that. For a end section joint, for an end section joints, there are only attaching section, but for a section to section joints like this one, there are owning section. In this case, the owning section is this one, SCT and C5, and the attached section is this one. This one is the attached section. Okay, this is the owning section and attached section definition. After that, the first question is O type. The answer we will get in the first set of selectors. In our case, the answer is beam. Okay, owning section has to have a G type, that is beam. Okay, only then you will see the base plate connection under the dialog box in PDMS design. Okay. Now the next set of question is A type, the attached section type. In our case, it can be anything. So you can connect any section having any sort of G type with a section having a G type of beam, and you will get all those connections that we are currently having here, flange. All those connections you will get. After that, the next question is S type. If we click on the next set of selectors to get the answer of that, we will check the answer of that S type question is FLAN, and the description of S type or subtype is column flange. This description will come under the graphical user interface of subtype column flange. Okay. After that, there is these are all the spec components. Definitely these are all the spec components, and the name of the category reference of the spec component is referred in this tab. Okay, name of the category reference of the spec component is referred in this tab. This is a common specification procedure. Okay, so now I have already told you that the purpose of the specification is very important actually. So suppose this is the base plate specification. Okay, now this is a joint, so definitely the purpose is joint. Okay, obviously. So now if you click it here and suppose let me for a reference just delete this for once actually, just delete it. Now if you go to modify joint specification and click it here, you can see that base plate connection specification is available. Okay, you can create the base plate like before you can create it, but just delete it once again. Okay, now I've deleted it. Now I will go to Paragon again. Now till now the purpose is join. Okay, now if I change it to anything like STL or something like that, now the purpose is changed. This is the structural purpose. Okay, so now if I save it, and now if I do a get work and save work, and now if I go to modify joints and specifications and then click on this, then the tab will be displayed. But if you go here now, you will not see that base plate connection thing. The base plate connection specification is not displayed here. The base plate connection specification is not displayed here. Why? Because I have changed the purpose of this specification. So the purpose is very important to display all those specifications that are required in certain GUI graphical user interface dialog boxes. So now again I have changed it to join and I have saved it. Now again I will do one get work and one save work. Okay, now again I will go to modify joint specifications. I will click it here. It is created. Now you can see this base plate connection is available again. Why? Because the specification purpose again has changed to its JOIN. Why JOIN? Because this is a joint specification. That is why JOIN. For fitting specification, if it will be FITT. For structural specification, it will be STL. For piping specification, it will be PIPE like that. Okay. So for base plate, again we have to select it base plate like that. If there are any design parameter like bolt or something like that, you can change it. And after that, if you click apply, it will be displayed like that. So it is the general working procedure. So this is how you create an intersection joint or a section to section joints. And I have explained all the details regarding the working philosophy between Paragon and design, and how all those specification, all those category reference are related, are correlated in between design and Paragon. Why this is important? This is very important because in the later sessions, while I'm going to discuss different category selection, category creation or specification creation for different joints and fittings and more details, then this knowledge will come into play. Okay. Thank you for today. We will check in a later episode.